In the mid-1800s, when scientists were working to increase the efficiency of steam engines, they noticed that you could take work and convert it to heat. And this was capable to be done at 100% efficiency. So you can take work, produce heat at 100% efficiency. But if you want to go the opposite direction, if you want to go from heat to work, then you can't get 100% efficiency in the reverse direction. So there's a natural asymmetry to this process. So we take heat and produce work with it every day in society. So your car engine is a heat engine. We burn fuel to produce heat, which then we use to extract work from the engine. A jet engine does the same thing. We burn jet fuel, we produce heat to get work from the engine. So going one direction, we can do 100% efficiency. Going the other direction, we can't get 100% efficiency. And we want something to describe this asymmetry as well. So we can use what's called the entropy to describe this asymmetry and to predict which direction is spontaneous for a process. So the entropy was developed in the mid-1800s when scientists were looking at steam engines, and the entropy can tell us which direction is spontaneous for a process. So let's consider the simplest type of system. So in order to understand this, we need to do a couple of definitions that you might have seen in the first semester. The system, the surroundings, and the universe. The system is what we're interested in. It could be a chemical reaction, it could be a heat engine, a car engine, or a jet engine. It could be a steam turbine. Whatever we're interested in is the system. The surroundings is everything else. So everything that surrounds the system. And the universe is equal to the system plus its surroundings. So we have these definitions. Let's consider first a system that is isolated. Okay, so I have some system here. It could be a chemical reaction, it could be a heat engine, whatever. And say I have a barrier between the system and the surroundings. And this barrier will not allow heat, work, or matter to exchange between the system and the surroundings. So no heat, no work, and no matter can be exchanged between the system and its surroundings. This is called an isolated system. And in an isolated system, if a process is spontaneous, then the change in entropy for that process is positive. So we use the letter S to stand for entropy. So if a system is spontaneous, that occurs naturally in an isolated system, then the entropy change is going to be positive. If the entropy change is negative, it's not spontaneous. So the entropy gives us a way to predict a process, whether it's spontaneous or not, in an isolated system. So in real life, systems aren't isolated. Our heat engine interacts with the air and the surroundings. So heat can flow from our engine into the surroundings. So it's not an isolated system. So how can we use entropy to predict processes when a system's not isolated? So now, let's say we have a system that allows heat, work, or matter to be exchanged with its surroundings. So we can predict the spontaneity of the process by looking at the delta S, change in entropy of the universe. And this is just equal to the change in entropy of the process for the system plus the change in entropy of the process for the surroundings. And if we have a system that interacts with the surroundings, then in order for a process to be spontaneous, the entropy of the universe has to be positive. And if delta S of the universe is negative, it's not spontaneous. So for any process to occur, it has to be spontaneous or it wouldn't occur for the universe. So then everything that occurs in our universe has a delta S of positive value. So the entropy of the universe is always increasing. It can never decrease. We can have a system change in entropy that's negative. So we can decrease the entropy of the system so we can have a non-spontaneous part of the system. But if we're going to have a spontaneous process in the universe, delta S of the surroundings has to be positive and greater magnitude to make up for it. So for any process to occur in the universe, for a system that interacts with its surroundings, delta S of the universe has to be positive. So this is kind of an arrow of time. Everything that happens in the universe happens with an increase in entropy.